Okay, so solve using the quadratic formula. So one formula that students typically remember maybe from high school is the quadratic formula. So quadratic formula comes from ax squared plus bx plus c equal to 0. So it's a generic quadratic equation where a is assumed to be positive. Okay, so it's not equal to 0, it's positive. And if this is the case, then we can use completing the square on that thing right there to get the formula for the solution to the quadratic equation. Namely, x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. Okay? So this is the infamous quadratic formula right here. Okay, so make sure you've got this written down somewhere. Definitely gonna need this. All right. So quadratic formula. Let's use it. So here's an example. 4x squared minus 3x equals negative 1. In order to use the quadratic formula, there's two things you need to note. Number one, it needs to be set equal to 0. Okay? Number two, a needs to be positive. Okay? Once you get a positive and the whole thing equal to 0, then we can go from there. Right now, when I look at this problem here, my a is positive, so check 1, but it's not equal to 0, right? It's not equal to 0, it's equal to negative 1. So how do I fix that? I'm going to add 1 to both sides. And so when I do that, I get 4x squared minus 3x plus 1 equals 0. Now I can look at the coefficients and the constants, and I say a is equal to 4, b is equal to negative 3, and c is equal to 1. So I use the quadratic formula, x equals, and then parentheses. This is where people mess up. They don't use their parentheses. So use your parentheses around everything. Negative 3 plus or minus the square root, parentheses, negative 3 squared minus 4 times parentheses. A was 4 and c is 1. Close it, and then divided by 2a. If you use your parentheses, you're going to get this right, okay? Use your parentheses. Negative and a negative make a positive 3, plus or minus the square root. Now, negative 3 squared is 9, and then minus, and then 4 times 4 is 16, times 1 is 16, over 2 times 4 is 8. So what does this get me? This gets me 3 plus or minus the square root of, ooh, that looks like a negative number. That is negative 7 over 8. Okay, what do I do with the square root of a negative number? First thing I do is I pull the I out. So I have 3 plus or minus I square root 7 over 8. And that is good enough for me. If it asks you to write it as two answers, this plus minus can be broken up into x equals 3 plus I square root 7 over 8, or x equals 3 minus I square root 7 over 8. Okay, so those are your two answers. Okay? Let's try another one. Make sure we really got this down. Okay? Quadratic formula, pretty cool. It's just like the complete the square, only it's a formula for complete the square. And so complete the square works for all quadratics. Quadratic formula works for any quadratic you want to throw at it. As long as a you make it positive, and then you set the quadratic equal to 0, then you're good to go. So we'll do one more of these. So 3x squared plus 5x minus 2 equal to 0. Now, with this problem right here, what we'll do, well, it's already set equal to 0, so we're good there. And a is greater than 1, so all we have to do is just write out the terms. 3, b is 5, and c is negative 2. Okay? So x equals, and then negative b plus or minus square root b squared minus 4ac over 2a. So this is negative, and then parentheses 5 plus or minus square root parentheses 5 squared minus 4 times ac over 2a. I'm telling you, if you write your parentheses, it's not going to be that big a deal. So this is negative 5 plus or minus square root. Now that's 25, and then minus and a minus make a plus. So what is that going to be? That's like 25 plus. Now 3 times 2 is 6 times 4. That's 24. So that's 49. And then in the denominator, 2 times 3 is 6. Square root of 49 is 7. So that's negative 5 plus or minus 7 over 6. Now, I see students leave it like this. It kind of makes me a little bit like, why'd you not complete it, right? So I'm going to ask you to simplify this a little more. So there's two things. You have x equals negative 5 plus 7 over 6, or x equals negative 5 minus 7 over 6. So this can be 2 over 6, which is 1/3. Okay, see how much nicer that looks. And this is going to be negative 12 over 6, which is negative 2. So my answer is 1/3 and negative 2. Now, did you notice something here? Your solution, the solution were two real numbers here, but the solution here were two imaginary numbers. And if you had to write this in your imaginary box in your homework, and it's like blank plus blank I, right? How would you write that? That fraction right there, this 8 divides both of those pieces, right? So this is like 3 over 8, and this is like square root 7 over 8. Okay, so that's how you would represent that into your box form. Okay, so and then this one would be like a 3 over 8, and this would be a plus a negative square root 7 over 8i. Okay? So let me zoom in there so you can kind of see how that represents. Okay. So you had two real solutions, two imaginary solutions here. All right? Now, what are all the scenarios? You might be asking yourself, well, really, where does it really depend on? It depends on this number inside the house, right? Inside the radical. If the number inside the radical is a positive number, you're not going to have any issues. It's going to be a real, right? If the number inside the radical is a negative number, then the answer is going to be imaginary. So really, I think all we have to look at is this thing right here. And this thing has a special name. B squared minus 4ac. This is known as the discriminant, okay? So if the discriminant, that thing inside the radical is positive, greater than 0, what does that tell me? That tells me the quadratic equation, when I graph it, has two real solutions. Okay, it has two real solutions. So there's two real solutions here. However, if b squared minus 4ac is less than 0, kind of like this scenario we had here where we had the negative 7, it gave us I and negative I, right? Okay, I are non-real solutions, so this would be the scenario like this. It never crosses that parabola, never crosses, so there's no real solution, okay? But there are two imaginary solutions. Okay, two imaginary solutions. Okay? So there's one more scenario, and can you think about what that scenario might be? If you think about it, okay, if you think about it here, what's going on? Well, you can either have 2, you can have none, or you could have exactly one solution, right? So the other scenario would be where we have exactly one solution, okay? So one real solution. Well, how would this be the case? Well, that plus or minus causes us to have 2 solutions, right? But what if we plus or minus 0? If I plus or minus 0, does that change anything? That'd be like -5 plus or minus 0 over 6. Now, plus or minus 0, that's not going to be anything different than -5 over 6 for both of them, right? So if the last scenario, if it's not positive, it's not negative, then the discriminant is equal to exactly 0, then we have one real solution there. That's the idea, okay? So, and then we'll talk about this more later on in the class, but the multiplicity, at this point here, the multiplicity is equal to 2, okay? So technically there are 2 real answers, but it's like it's the same real answer. So if this is like 1, 0 for my solution right there, that's like saying like I had x equals 1, x equals 1 for both of those. So that would be the scenario. It would be like x minus 1 squared would be this parabola. That's x squared minus 2x plus 1 equal to 0. Okay? And if you ran through that scenario, a is 1. If you run through this, that's negative b, so it's -2 plus or minus square root. Now that's b squared. Okay, b squared is -2 squared minus 4 times ac all over 2a. What does that get you? That gets you 2 plus or minus. Now, -2 squared is 4, and then minus 4 gets you 0 over 2. So that gets you 2 plus 0 over 2, or 2 minus 0 over 2, which is 1 or 1. So that's telling me x equals 1 or x equals 1. It's a little redundant, right? So that's why we say there's a multiplicity of 2 there. Okay, so that's kind of what's going on. So really all you have to look at to know how many real solutions there are is the discriminant. And if it's 0, there's only 1. If it's less than 0, it's negative, then there's no real solution but 2 imaginary. And if the discriminant is positive, then there's 2 real solutions. Like right here, we had 2 real solutions. My discriminant was positive. Okay, b squared minus 4ac was 49. Here, the discriminant here, when we typed it in, we got what? We got -7. It's a negative number. There were no real solutions here. Okay, guys, good luck as you